Yes, we can start.
Good evening, everyone. A very warm welcome to all of you to another session of our industry-oriented training on Python programming for AI and data analytics. In our previous session, we explored machine learning fundamentals, data pre-processing, feature engineering, and the process of building predictive models. Today, we move to a critical stage of machine learning workflow, model evaluation. Today's lecture will focus on important evaluation metrics, including accuracy, precision, recall, F1 score, ROC, and the confusion matrix. Building a machine learning model is only the first step. You also need to understand how well that model performs and whether its predictions can be trusted. Different evaluation metrics provide different perspectives on model performance and help us choose the right model for a particular problem. We will explore how these metrics are calculated and, most importantly, when and why each metric should be used. Understanding these concepts is particularly important in real-world applications, where simply achieving high accuracy may not always mean that a model is performing efficiently. I encourage everyone to actively participate, follow along with the practical demonstrations, and relate today's concepts to the classifications model we have already discussed. Developing strong model evaluation skills is essential for building reliable and responsible AI and machine learning solutions. It is now my pleasure to welcome our esteemed mentor and speaker, Dr. Meher Chand, Associate Professor at Bafarid College of Engineering and Technology, Bathinda. Through his expertise in AI, machine learning, computational sciences, and data analytics, he continues to provide learners with practical knowledge and an industry-oriented approach. With great pleasure, I invite Dr. Meher Chand to kindly lead us into today's session. Over to you, sir.
Thanks, dear Face, for the nice introduction. And dear participant, today the main core part of the machine learning, when we have established any model, the challenge is the model evaluation matrices. So here I have prepared the complete and comprehensive guide. And following this, just by taking some overview about the what we are required, which type of the tests are there. Then after we also demonstrate with the help of Jupyter notebook. Okay, so I am sure when you will complete this comprehensive guide, why we need all these tests, what are essential, how you can do perform, and what are the meaning of the accuracy of all type of the model, the values which we are getting, specifically the different type of test which we are going to implement. Okay, so here you can see uh, the model, the file. Okay, so building a machine learning model is not enough. After training a model, we need to answer a very important question. And the question is, how well is our model actually performing? We cannot always answer this question simply by looking at accuracy. Different applications have different requirement in healthcare. For example, missing the disease case may be much more serious than generating a fast alarm. Okay, so therefore, in the today's this lecture, we will study 6 important classification evaluation concept, and we will start from the confusion matrix, accuracy, precision, recall, F1 score, ROC, AOC. Okay, the central idea of the today's lecture is there is no single best evaluation metric. Keep in mind, the appropriate metric depends on the data, the application, and the cost of different types of the data. Okay. So here, very first we have is the confusion matrix. As you can see here, this is confusion matrix. Just 1 minute. Okay. Yes. So this is the confusion matrix. What is a confusion matrix is the foundation of many classification matrices, and it compares what the model predict with what actually happened. For the binary classification problem, we have the four possibilities. First is true positive. Okay, the model predict the positive, and the actual result is also positive. Just like you can see, yesterday also we show you this matrix, as you can see here. On the left hand side, we have the actual negative, actual positive. These are the based on the data set. Okay, and on the top you can see this is the predicted negative and predicted positive. Okay, so when actual positive, actual negative and predict negative, in that case we have true negative. And if you will take the actual negative and predicted positive, that is the false positive. Then actual positive and predicted negative, we have false negative. Actual positive and predicted positive, we have true positive. So actually, this is the matrix, which is known as confusion matrix. Okay, for you can take the true positive. The example is a patient based on our healthcare data set. A patient actually has the disease, and our model correctly predicted that the patient has disease. Okay, the model predicted the negative, and actual result is negative. Then we have the true negative. For example, a healthy patient is correctly identified as healthy. Okay, just like as we have at this place, we have is the false positive. The model predicted the positive, but actual result is negative. Okay, so this is the we can also call it the type 1 error. Okay, a healthy patient is incorrectly classified as having a disease, and false negative, this is the also known as type 2 error. Okay, so the model predicted negative, but the actual result is positive. Okay, so example, you can take the patient has the disease, but our model predict that the patient is healthy. So this is type 2 error. Okay, so actually we are required to first understand that this matrix, what are the values, and here also we have clearly defined. Okay, all TP, TN, FN, FP. Okay, and what type of the error one and type 2 error, these last two one, when we fast negative and fast positive. So these are two type of the error and clearly defined here. And this file which I prepare is quite simple, but still we are required to spend time, because each concept is very, very important and we have to keep in mind all these. Then we can have understand better understanding about the test and when you will implement it. So these deep understanding will help you to interpret the model. Just like as you can see yesterday, I use here to integrate generative AI tools by using the ChatGPT. So you can see so many very long interpretation is there. Okay, because you are only on the very beginning stage, and the test which we are required to implement. Okay, we did not discuss. So today we are going to cover, and when we will discuss all these concepts, and when you will spend some time to understand all the parameters, how, okay, which type of the, actually the main thing is every test has some property, concept, condition, which we have to understand and keep in mind, because without understanding and for this test, okay, some time is required, because all the things are different, whatever you have studied in the previous or about your study. So if you will spend some time on the sheet, these are about 7 pages are there. Okay, and I think to understand these 7 pages, 1 hour is more than enough. Okay, so many things you will cover here. So why it matters? The confusion matrix reveals the type of error in your model mix, and a model with high accuracy might systematically misclassify a specific group. That's why something the confusion matrix immediately expose. For example is also given here. Okay, you can see. Imagine a medical diagnosis model. 950 correctly identify healthy patient. Healthy patient. Okay, and 40 correctly identify sick patient. That is TP. And 5 correctly labeled healthy as sick. That is false positive. And 5 incorrectly labeled sick as healthy, false negative. So this data tell us for more than a single accuracy score. Okay, so when you will have, so what about this one? Okay, so always examine the matrix before interpreting the classification. So there are some more parameters, and this matrix um, is very risky. Okay, as when you will compare here the results, this will be very risky. Okay, so the correctly identified healthy are this, and when the other value you see the very large change in the values. Okay, then you can see the accuracy, the intuitive matrix. So accuracy answer is a very simple question. How many prediction did the model get right out of all the predictions? Okay. Or simply we can say accuracy is the proportion of the correct prediction out of all the prediction made. And the formula, as you can see here, for accuracy is equal to TP plus TN upon TP plus TN plus FP plus FN. So this is the required formula. Okay. And in the simple, how many did we get right? Okay, so this is the strength, intuitive and easy to understand, useful when classes are balanced and good general purpose metric. Here is the weakness, misleading with the imbalanced data. If 95% of your data is one class, a model that to predict everything is the class achieve 95% accuracy while being useless. Doesn't distinguish between type of the error. Okay, and third one is ignore the cost of a different mistake. For example, you can see here medical diagnosis example we can take here. Accuracy is 99%. Okay, looks great, but those 5 missed sick patient could be serious. Okay, the patient which was missed here, okay, that can be more serious. Okay, so when to use balanced data set? When false positive and false negative carry equal weight. Just like as you can see the values which you will get at this place. What are the values of Tn? What are the values of Fn? What are the value of Fp and Fn and Tp? Okay, so we are required to compare these values, then we will get to able to understand. Okay, so where you need to focus. So when this is the only the about the idea what we are going to and how we can do. Okay, and when we will check the real example, then you will have more clarity about the this test. So similarly, we can have the accuracy we have discussed. Okay, okay, this is the accuracy intuitive matrix. So accuracy is the proportion of the correct prediction out of all prediction made. Okay, so you can see here true positive, true negative. Okay, These are the correct prediction out of all predictions. So these are the all predictions which has been done, but these are the true prediction. Okay, either true positive or true negative. So in the simpler way, we can say the strength, intuitive and easy to understand, useful when classes are balanced, good general purpose metric, and weakness. See here the weakness. So everything which we are required to understand are clearly defined here. And as soon as you will go through the entire file, okay, and understand the concept, compare the values, then when you will have the matrix, confusion matrix, compare all these values. And sometimes if you have still there is any confusion, because uh, this will take time to understand everything. Okay, so the analysis of the model, when you implement and you have the accuracy is of your model is more than 99%, and still the evaluation of the model is more important, and all these tests which we are going to discuss surely will help you. And when actually one method, as we discussed in the very beginning, one method is not sufficient, and we can't say on the basis of a single method whether the testing is justified. Okay, so we have to check by applying all the tests which we are going to discuss here. There are 6 methods are there. So if you will compare all these tests which we are going to implement, and then you will compare, then it will help you. So on the basis of this one, you can see the weakness about the model, misleading with imbalanced data. If 95% of your data is one class, a model that predict everything, that is 95% accuracy and doesn't distinguish between the type of error. Ignore the cost different mistake. And you can see the example. Okay. So look at the date, but 5 missed sick patient. Okay, I have covered this part. Okay. So then we have the precision also. Okay. Uh, Quality of positive prediction. Precision means quality of positive prediction. Okay, so when my model predict positive, how often is it right? And formula you can see here, we have uh, just like TP upon TP plus Fn. Okay, so for all the positive prediction, how many were actually correct? So this is the interpretation of the above. We can easily do high precision means few false alarm, and your positive prediction are reliable. And the strength of this test we have critical when false positive are costly, and can I trust this positive prediction? And weakness, see the example. Okay, medical diagnosis precision. I have the values which we are computing in our matrix. Suppose that for these are 40, and the other is according to the formula. See here the formula. So TP is 40 and FP is 5. Okay. So by applying this test, we can have 88.9%. Okay. On the patients, we flagged sick 88.9, actually were sick 11.1%. So were the false alarm. So when you can use, you can see the everything detail is there. Okay, then last we have the recall coverage of actual positive. Okay, you can go through this detail. Okay, so recall is also called the sensitivity answer. Okay, so how many of all the actual positive cases, how many did I catch? The formula for the recall we have is TP upon TP plus Fn. Okay, so when you will implement, and this is the interpretation which we can go through here. So high recall means few missed positive, and we are catching most of the prompt cases. you can see the strength and we can see the weakness. Okay, critical when false negative are costly, and I am missing cases I should catch. Okay, then says the nothing about the false positive, and see the example medical diagnosis. So here we have recall is 88.9%. Okay, so if it is 88.9%, then what? So among four identified as sick, approximately 88.9 were actually sick. The remaining prediction were false alarm. Okay, so when we can apply this okay, recall. Just 1 minute. Okay. So when we can apply, and why is recall important? Recall is particularly important when false negative are costly. For example, we can take from the healthcare. Okay, cancer detection, disease screening, fraud detection, safety monitoring. In cancer detection, for the example, suppose that missing a genuine cancer case can be much more serious than sending a patient for the additional test. Okay, so when missing a positive case is dangerous, we usually prioritize recall. Okay, so if you are required comparison between all these, uh, we can add on some more content. But for the understanding, all these are very, very important. Then we have the F1 score. Okay, F1 score, they balance the metric. Okay, so for this one, sometimes we don't want to look at precision and recall separately. We want one metric that combine both. So for that, we have is F1 score. Okay, and F1 score is a harmonic mean of uh, one is precision and the second is recall. And you can see the formula to multiplied by precision into recall upon precision plus recall. So this is the formula to calculate. Okay. And more directly also you can see here 2 cross TP upon, you can see 2 times TP plus FP plus FN. Okay. So directly from the confusion matrix, we can have this one. So mostly we are using the first one, this one. Okay. So what is interpretation about this test? Okay. So suppose that uh, when we are computing the values and the score we have is about okay, in the example we have given the score also. Okay, so precision is 90% and recall we have is 10%. And if you will take the arithmetic mean, that is 50%. And harmonic mean we have is 18%. Why? Okay, because F1 strongly penalizes the situation where one of the precision or recall is very low. Okay, just like you can see, one of them is very low. One is precision is 90%, recall is 10%. See the difference between them. Okay, so harmonic mean tell us that despite high precision, the poor recall is a serious problem. And this can be possible by using this F1 harmonic mean. Okay, so sometimes we are not able to calculate, understand the comparison between these two, but F1 test will make it easy. Okay, so the strength and weakness are given here. And here is one more example based on the medical diagnosis. And when you will get the value is 88.9%. Okay, so when to use the when imbalanced data set, especially common in the real world problem. And when you want a single metric that considers both false positive and fast and active. Okay, so as a summary metric for the model comparison, so this will help you to use this model. Okay, actually that is the theoretical part, and when we will use all this in the real data set. So the concept which we are going to discuss and different formulas are there. Okay, so all these will help you to implement and to analyze the report, and what mathematics formulas are there, and these conditions, and when these are required to implement, spend some time in the theoretical part. So as much you have the theoretical part more clear, okay, you this will help you for the sorry, better understanding and for the better interpretation. So now next we have is the ROC curve and AOC curve. Okay, so just one minute. Sorry. So here ROC means receiver operating characteristics. Okay, so the ROC curve is different from the previous metric because it evaluates model performance across different classification threshold. Okay, so it has a false positive rate. We can see here. Yes, on x-axis we have false positive rate, FPR. And the formula is given here, Fp upon Fp plus Tn. On the basis of this, we will calculate the value. That is false positive rate. Okay. And the second is true positive rate, TPR, on the y-axis, which is recall. Okay. So these two values we will calculate for ROC curve. Okay. As you can see here on the horizontal side, this is the FPR. Okay. And on the vertical line, we can have TPR. Okay. So as your model, these values will be increased. So initially random guessing diagonal will be there. And in the middle, we have actually this will be in the three parts. Okay. So in the beginning, this is the random guessing. Then we have the model, and then we have the perfect classifiers. You will see on the top. Okay. See here when you will implement for the real data set. So the perfect model curve reaches top left corner. Okay, top left corner. High TPR, low FPR. Okay, and random model diagnose line at 45 degree, and real model falls somewhere between. Okay, so this can be fall anywhere when you will implement, and when you will implement this concept when we will plot the graph. Okay, then we have the AUC curve. Okay, so the understanding of the ROC curve is also very, very important. A perfect classifier reaches the top left corner if we have the perfect classifier. So this will be always top left corner. Okay, why? Because very high true positive rate and very low false positive rate on the basis of these values. Okay, we want very high true positive rate. Positive rate must be very high, and false negative rate must be very low on the basis of this parametric when we will plot. Okay, so the perfect classifier will always be, keep in mind, top left corner. Okay, so the random classifier is represented approximately by the diagonal line. Okay, and a real model usually falls somewhere between the random classifier and the perfect classifier. In between these two, this will fall our model, as you can see at this place. Okay, here in the middle, on the top, and from this line, at this place, this will lie our model. Okay. So now we have the area of AOC curve. Okay. So this is the numerical values which you can see here, and on the basis of these value, and range will be from 0 to 1. So AOC curve area under curve specifically will be lies between 0 to 1. So AOC quantifies the ROC curve as a single number, and the probability that the model ranks a random positive example higher than a random negative example. So see the values when you will calculate AOC. If that is 0.5 random guessing, and 0.7 to 0.8 acceptable, and if 0.8 to 0.9 excellent, and if it is 0.9 plus exceptional. Okay, so these values, when you will keep in mind, remember, so these values will help you in the interpretation. Okay, because the theoretical part is very, very essential for this test. Okay, so somewhat what we have done yesterday, you have the idea we are required to implement test, and we get some values. But what are the meaning of these values? So for that, this chapter which I have prepared, okay, you have to go through this one, and first time you can have some doubt. Okay, second time you will read, some doubts will still be there. If you will spend 2 or 3 days, after that also minor doubts will be there, until when you will implement for real data set, and when you will do as I very in the beginning told you that when you will complete 2 or 3 model. Okay, because uh, when you will implement 2, 3 model, you have some practice, and you will be able to compare all these different type of problems, and when you will observe that the same things are there, and you will focus on specifically this part. Without having this part, okay, we know when we have the challenge and where will be the problem, and which part we are required to more focus, concentrate. Definitely we will do accordingly. Okay, so now only to establish the model is not sufficient if we don't have evaluation of the model. Okay, so here you can see also some type of the strength or weakness as we have studied in the previous one. Okay, so this is the way choosing the right metric and decision framework for balanced data. If data is balanced, start with accuracy, add precision and recall, and then summary, F1 score. These three are required. If we have imbalanced data set, avoid accuracy, primary precision and recall, summary F1, and for threshold, ROC, AOC is essential. Okay, for domain specific application, just like a medical diagnosis, so here are defined, prioritize, recall. Okay, missing cases is dangerous, and also check precision, false alarm. Okay, harm patient, and use F1 score or ROC, AOC. So also these are also defined here, which test when you can apply in which cases. So spam, for the spam detection, you can use precision, recall, F1 score. And for the fraud detection, you can use recall, precision, and F1 score, ROC, AOC. For the loan approval, so various examples are given here. And this is the practical workflow. Okay, how you can do, and this is the summary table about all the tests, what they will do, and how what they measure best for and weakness. Okay, so when you will go through this entire table and you will study all the concept, so this is the all about the overview about these matrices, and I'm sure when you will spend some time and understand these parameters for application part. I'm sure this will help you for the better understanding about the evaluation of the test which you are going to apply for your model. Okay. Okay. So is there now any doubt? Is there any doubt now? I think you need to spend some time on this part. Don't worry. If you right now don't have any question, I will share this file with you. You must go through this file. Okay. You have the time. And tomorrow, when we will start the session, in the very beginning, either you will ask the question, okay, or if you will not ask the question, then I will ask the questions from you. Okay, so one side there will be questions. Either you will ask or I will ask from you. Okay, so now you can see all these things in this Jupyter file, okay, which I have prepared and specifically for all these tests. Okay, so first you are required, and yesterday the file also you will find all these modules for testing, NumPy, Pandas, Matplotlib, Python, as we know. And for the matrices which we are required, you can see here. Okay, so all these libraries are essential. Then after we have the, as we discuss here, the information is clearly, we are always start by using confusion matrix. Okay, so this part we have already discussed. Here is the example. Okay, here is the example. Okay, X test we have this value and Y prediction we have these values. So here we are creating the confusion matrix. So what is there actually when you will create the confusion matrix? We have these values. Okay, this is the value of TP. Then this is TN. This is the value of FP. This is the value of FN. Okay, these are the values which will be calculated. Now we are required to interpret all these values, and for that you have to compare. Okay, and visualize the confusion matrix. You can see here the confusion matrix in visualization. Okay, so you can see this part, this and this. These are the values which we compute. Okay, now again, after that, we are required to compute just like accuracy, limitation, okay, by using these values. So this is the confusion matrix, and now come to for the accuracy. This is the accuracy formula we have discussed, and now we are presenting here. Accuracy is 80%. Okay, so accuracy can be misleading for high imbalanced data set. Okay, so here, what about these values? Okay, copy. Okay, and in the beginning you will have the challenge. So as I do yesterday, you can take help from, sorry. Yes. So what are the meaning of these values which we get? Okay. So here interpret. Okay, so here when you will do, so all the calculations which you are required. Okay, because in the very beginning, when you will try to use, when you will integrate this one with your model. So how we are doing? So the actual values, actual and predicted, all these values are there, which we can have. Okay, so this is the matrix which we are using, known as confusion matrix, and these are the values at true negative, false positive, false negative, etc. Okay, and this is the overall accuracy is 10. Then correct prediction we have is 8. Accuracy is 0.8. By using all these values with the help of the formula, we are computing. Okay, so all the values has been calculated here. So precision is 0.80, recall is 0.80, F1 is 0.80. What is the meaning of this one? Because the matrix is symmetric, the model has the same performance for both cases. Okay, when you will see the fusion matrix, so that is symmetrical. What is the meaning of symmetrical? This value and this value. When you will see the symmetric value, so about this diagonal, the values are same. Okay, so when you will now come to the conclusion, this is important. On the basis of these outputs, which you calculate the precision, recall, F1, this will help you for the better understanding. So in this way, you will try 2, 3, 4 examples by using in this way. And when you will get the value and take the help from this place, okay, automatically you have self-learning. Okay, so when you will go through here, what is the meaning of a matrix indicate that the classification model correctly classified 8 out of 10 observation, and resulting you can find Mr. Jitendra Kumar, your mic is unmuted. Please, I request you mute it. Okay, and resulting in overall accuracy we have 80%. The model correctly identified 4 instances from each class. Okay, so while in instance from each class was misclassified. Okay, so overall the model demonstrated good and balanced predictive, although 2 observations were incorrectly classified. Okay, so then also the same, I think, yes, come to here. Okay, so in this way, try to understand this part. And yesterday also I demonstrate with the help of generative AI, you can help from the generative AI for more elaboration and understanding. Okay, so then after the same thing we have visualized in the matrix form. Then we have calculated the accuracy. Okay, the formula is there. These what are the limitation? Accuracy can be misleading for high imbalance data set. For example, if 90% of the 95% of the patients are healthy, a model predicted healthy for every can achieve 95% accuracy while failing to detect the any disease case. Okay, so if there are some cases, 5% which are left, and if there are 5% cases are very serious, so this is the very dangerous case. Okay, so here you can see the accuracy percentage according to the values which we have taken here, and these are 80%. So this is the example which they taken here. Okay, but in our data set which we have taken at place by example, this one, on the basis of this example and the confusion matrix, we have accuracy is 80%. Similarly, we can have the precision. The formula is also I put here, and how you can calculate everything is there. Okay, precision, and how you can calculate the percentage. Okay, that is also 80% here. Recall when you will check, that is also 80%. And F1 score when you will check, that is also 80%. Okay, then after we are required complete classification report. So here is the complete classification report. When you will apply this the classification report, okay, you will have this type of the matrix which you are observing here. Okay, the interpretation of this part is very, very important. Okay, so here what you are observing, precision values are there. These are the recall values. This is the F1 score. Okay, and the accuracy case also you can see here. These are the number of disease. Okay, and spot values. And but here actually the thing is the all the values are equal due to symmetrical. So not much more interpretation is possible. Okay, but as you have the different values and when you will get, but here we have the not accurate prediction which we can say. Then we have the ROC curve. Okay, for the ROC curve, we have discussed already TPR and FPR, these values are required, and probability score for ROC analysis. We have hypothetical predicted probabilities for the positive cases we have in this y variable. Okay, these are the probabilities. Then we are need to required how you can calculate. So first you are required to create this array. Then after you will apply FPR, TPR, these two values are required, and threshold will be there because these values are calculated on the basis of the threshold. Okay, so this is the method how you can calculate this value. ROC curve, Y test, Y probability. Okay, these functions are there in our machine learning model. From that place, you will choose these two variable, Y test, Y probability, and AUC score. You will use ROC underscore AUC underscore score. Okay, Y test, Y probability. So when you will execute, this will fit ROC AUC by using AUC underscore score 0.4f. Okay, so you know what is the meaning of this one. So 4 decimal places up to we will take, and when you will execute, you see these values. So here you can see 0.96%. This is the main part. This is the main value. Okay, so our model is 96% accurate. Okay, then we plot the value. See this I want to say this one. Okay, so this is the random classifier. Okay, and this is the in the blue color which you are observing, this is the ROC. So as we discussed that the model lies between here, always on the left top corner. You can see this is the left top corner. Okay, for a different data set, this will be in a different way, but this value will always be on the left side. This is the false positive, and this is the true positive rate. So under on the basis of these two values, we can have this curve, ROC curve. Okay, so here we have AOC, area under ROC curve, and these values, as we discussed, one excellent, 0.291, very good. Okay, here is 0.921. Okay, okay. Okay, very good. Then we have 0.8 to 0.9. Good. This is fair. And if the values are 0.5, approximately random. Okay, so on the basis of the values which you will get, must be interpreted on these values. And this is the comparing all major matrices. Okay, so here accuracy, precision, recall, F1 score, ROC, AOC. So all these we are comparing here. And this is the matrix. Okay, and here we have accuracy, precision, recall, F1 score, ROC, AOC curve, and all these are at the same level. ROC, AOC is at this place. Okay, so all these we have 80%, and this is about 95%. So this is the graphically representation, because when you will do, we have to present all these interpretation graphically, so that whenever anyone want to check, so this graphical will help them to understand all type of the interpretation which you have made. Okay, so here which matrix you should choose. We have discussed already in the file which I have shared with you. Okay, so this is the evaluation workflow which you are required to follow. Okay, and these are the key takeaways. So most of the content I try to cover in this file, which are also in the PDF file. Okay, so both are almost similar. So that when you will study the PDF file, and after that when you will switch on this Jupyter file, so there this can be easily understandable. So dear participant, this is all about the today's session, and if any question, please you can unmute your mic. Okay, I think you are required to spend and go through the detail. Then there will be some question. So I will not spend more time. So tomorrow in the coming session, be ready. Either you will ask the question or I will ask the question. Okay. So try to understand all this content which I present here. And this is the most core part of the machine learning. To develop the model, not a big task, but how much your model is accurate or validate. That is the most important. Okay. So come with your preparation in the coming sessions. And also all this is the complete workflow I present here. And if you are working on different models, okay, you must apply all these. But depend upon your data set, whether these are required or not. Okay. So how you will validate your model is very, very essential. So for each model, we have to validate. Okay. So now, dear friends, this is the time. If you don't have any question, we can conclude. Dear participant, please reply me yes, no. For those people who don't have mathematics background, specifically those people from medical science or health science. Okay, so please don't worry. If sometimes, yes, we understand the gap of the test, and sometimes because when one participant is from the medical background, and we understand that mathematics concept will take more time to understand. Okay, but actually the thing is one thing you understand what are the purpose of this test to implement. Okay, one thing. So according to the your prompt, you can choose them, you can apply, you can have some outputs. Okay, as I show you at this place. Okay, you will have some values. Okay, so when you have some values, but sometimes if you are not able to interpret, I told. Okay. Sorry for the interruption due to electric cut. My system was shut down. Okay, now I request to Face, please conclude the session.
Yes, sir. As we conclude today's session, I would like to extend my sincere gratitude to Dr. Meherchand for his insightful lecture on model evaluation metrics. Today's session helped us understand how to assess the performance of machine learning models using accuracy, precision, recall, F1 score, ROC, and the confusion matrix. We learned that evaluating a model goes beyond simply looking at its accuracy and that different metrics provide different perspectives on how reliably a model performs. I encourage everyone to revisit today's concepts and practice applying these metrics to classification problems. A strong understanding of model evaluation is essential for developing reliable and effective machine learning AI solutions. I would also like to thank all participants for your active participation, thoughtful questions, and continued enthusiasm throughout today's training program. Thank you all for joining us today. Have a wonderful night, and we look forward to seeing you in the next session.
Thanks, dear participant. And tomorrow we will start the session at the same time at PM. Okay. And all the content which I present here, you can find in your WhatsApp group. Thank you and good night.